11.0, solving quadratic equations by square roots and completing the square. So first we're going to start with solving using square roots. Now, how do we know that we can use square roots to solve this? There is only one x in this expression. It's not like a trinomial where it would be 3x squared plus 7x plus 4. This only has one x squared term in it, which means we can use square roots to finish it. So minus 4 on both sides, solve it like a linear equation. 3x equals 27, x squared, sorry. Then you divide by 3, and x squared equals 9. And now we take the square root of both sides, but 3 times 3 is 9, and negative 3 times negative 3 is 9. So we have two solutions, x equals plus 3 and negative 3. Positive 3 and negative 3. You can say plus or minus if you want to. I like to separate it so that it does look like two separate solutions. All right, look at this equation. It's a squared, it's quadratic, but it only has one x in it. So if it only has one x in it, we can use square roots, so solve it like a linear. So minus 4 again. So then we get 3 times 2x minus 5 squared equals 27. Similar process. Then we divide off the 3. Then we get the 2x minus 5 squared equals 9. Then we square root both sides so that the square and the square root cancel. But recall that on this one, when you take the square root of both sides, this results in a 3 and a negative 3. So what's happening is now these square and square root cancel. So we have 2x minus, I'm going to write it up here, 2x minus 5 equals a positive 3. And we also have 2x minus 5 equals negative 3. So we have two solutions, two different equations to finish here. So plus 5, 2x equals 8, so x equals 4. Plus 5, 2x equals 2. Divide by 2, so x equals 1. So x equals 4 and x equals 1. So don't forget to split it into your two solutions. All right, now we're going to talk about something called solving by completing the square. We're going to walk through where does this come from and why do we use it. So first thing we want to do is talk about how to expand something like this. So x minus 5 squared. What that really means is that there's two of them, x minus 5 times x minus 5. A common thing that I see students try to do is distribute that square and say that it's x squared plus 25, which is not correct. You're missing your middle term. So x times x is x squared, negative 5 times x is negative 5x, negative 5 times x is negative 5x, and negative 5 times negative 5 is a positive 25. So the correct answer to this problem would be x squared minus 10x plus 25. This is something called a perfect square trinomial. This perfect square trinomial exists because it came from a squared binomial. So anytime you go back and forth between a squared binomial and its expanded trinomial, it creates perfect square trinomials. Now, is this a perfect square trinomial? Let's find out. It says factor. So the factors of 25, it's going to be a 5 and a 5, which adds to 10. So that's going to be x plus 5 times x plus 5. Oh, look, it is. So x plus 5 squared. So x plus 10x plus 25 is also a perfect square trinomial. So what does that look like algebraically, like if we did it as a diagram? So it says finish the diagram below to create x squared plus 10x plus 25. So of course you could have written x squared and then 10 x's all in one, but we're trying to prove that this is a perfect square trinomial. So what we did was we took the 10x and we divided it in half so that we have 5 x's on this side and 5 x's on this side. So then how many ones would it take to finish this diagram? So I can see it's a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So it's going to take 5 times 5 which is 25 ones. So a perfect square trinomial, when we draw it as a diagram using, these are called algebra tiles. If we use algebra tiles to represent it, this box that we filled in is what's going to be called completing the square. So you're asking for what number, what value of ones would make your square complete. So let's try to do one that doesn't have a diagram. Let's just kind of visualize in our minds what would happen. So it says, how many ones would you need to add in order to complete this perfect square trinomial? So I have two chunks of it, x squared and a 6x. So if we're trying to make it a square, what are we going to do with the 6? We're going to divide the 6 by 2 to make it a 3 and a 3, similar to what we had before. So then it's going to be a 3 by 3, which is going to make our perfect square trinomial value 9. So x squared plus 6x plus 9 is a perfect square trinomial. And then when we write it as its factored pairs, you use the division. So think about this. So the 10 divided by 2 got us that 5x. So then if we rewrite this, we even did it up here, going all the way back, the same perfect square trinomial is written as x plus 5 squared. So when you write this factored, so how would you write this? Write it as a binomial squared. You just take the 6 divided by 2, and it would be x plus 3 squared, because 3 times 3 is 9, 3 plus 3 is 6. All right, how about one that's got a negative? It's still the same process, x squared minus 12x. So thinking about the type of x's, we've got negative 6 x's on one side and negative 6 x's on the other side. So negative 12 divided by 2 leaves us with a negative 6 by negative 6. If I drew it, let's see if I can do it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 by 6 leaves us with a positive 36 ones. So this value is always going to be a positive value, no matter what kind of middle term you're looking at. But when you write it as a binomial squared, you use the negative number from your b term. So it would be an x minus 6 squared. So why do we care about this? What is it used for? It's used for solving equations more efficiently. So take a look at this one. X squared minus 12x plus 36 equals 16. I can see here that there are two x's. So right now, I am not prepared for using square roots. I would really like to only have one x in this equation in order to solve it using square roots. What I do notice is that x squared minus 12x plus 36 is a perfect square trinomial. So x squared minus 12x plus 36 can be rewritten as x minus 6 squared equals 16. And by doing that, by factoring it into a perfect square trinomial, I now only have one x in this equation, which means I'm ready to use square roots and take the square root of both sides. So then I have x minus 6 equals a positive 4 and x minus 6 equals a negative 4. Plus 6, x equals 10, plus 6, x equals 2. So these perfect square trinomials can get us to a place where we can use square roots to finish the equation. Let's take a look at this one. So x squared minus 12x plus 50 equals 30. Now the factors of 50 don't create a perfect square trinomial. If this 50 were a 36 though, similar to the last problem, then our life would be better. So this is the mathematical process that you can use to do that. So first what we can do is move the 50 over. So subtract 50 away, because that's definitely a problem. So then we have x squared minus 12x equals negative 20. But what we can do mathematically is we can create a space for the perfect square trinomial value, so adding in the ones place. And when you add something to one side and you add the same thing to the other side, it creates equal equations. So we have x squared minus 12x, and then I'm going to leave a space, plus my perfect square trinomial 1's equals negative 20 plus my missing value. So if I add the same thing to both sides, it keeps the equation equal. So the perfect square trinomial for negative 12x is going to be 36. I'll use the other color. 36 and 36. And now it matches. X squared minus 12x plus 36 is now x minus 6 squared factored. And then we add those two together. Negative 20 and 36 is 16. And then you would solve it in the same way that we previously solved it. So it would be x equals 10 and x equals 2. So you're always trying to get it into the form where it's one single x and it's going to be a perfect square trinomial that turns into a binomial squared, so you can use the square roots. Let's try some more. So we've got x squared plus 10x minus 16 equals 56. This looks really similar to one of the problems that we had on the front, where it was x squared plus 10x, but the value that it used was 25. So that 25 is not there, but we want a 25. So we're going to fix it just like we did last time. Move the 16, it's an issue. So then we get x squared plus 10x. 59 plus 16 is going to be 75. Then we make space. We make space for our missing 1's value. So we're going to have x squared plus 10x plus my 1's value equals 75 plus my 1's value. So how many 1's does it take to complete this square? We've seen it several times now. 10 divided by 2 is 5. 5 squared is 25. And what we do to one side, we do to the other. So now I know that this perfect square trinomial factors into x plus 5 squared, and 75 plus 25 is 100. Now I'm ready to take the square root of both sides. So we get x plus 5 equals a positive 10, and x plus 5 equals a negative 10. So then minus 5, x equals 5. Minus 5, x equals negative 15. Why don't you try number 4 on your own? So to get the 1's value that's missing, you would do 28 divided by 2, which is negative 14. Negative 14 squared is 196. 204 and 196 created that right-hand side to be 400, and then you can solve it using square roots. Again, why do we care about this? We're going to use it this chapter for some foundational algebra for circles. There's a lot of squared values, and we're going to complete the square pretty frequently. We use it in quadratic formula sometimes. It's also the same thing as the vertex form of a parabola. You can use it to find the inverse of a quadratic function. And finally, this is where we're going to use it in circles and conic sections in the next lesson. This is in Algebra 2 and beyond. Thank you.